Hello everyone, this is Kunika Chandra from Shivaji College, Delhi University. Currently, I am in the second year of my course BSc Physical Sciences with Chemistry, and today, as a part of the teacher internship program, I will be taking a topic of organic chemistry called peptides in this lecture. Before starting the lecture, let's have an overview. This lecture is divided into two parts. The first part would be covered in this video, where we'll be talking about the basics of peptides, what is a peptide bond, what are dipeptides, tripeptides, and the N and C terminal of a peptide. The second topic we'll be doing is the end group analysis, where we will be analyzing that how do we determine what amino acid is there on the N terminal and the C terminal of a peptide. We'll be doing it by three different methods. Starting with the basic definition of peptides, we'll have a simpler look at how they're made. So, for making them, we have to take two amino acids. For example, I've taken glycine and alanine over here, and with their functional groups, we join them to make a simple peptide. In this slide, we're going to have a clear look at what a peptide bond is and how it is present in a peptide. So while making a peptide from the two initial amino acids, water is eliminated through this way and we get a special CONH called the amide bond, and it is a special type of amide bond which is called as peptide bond, and it is present in every peptide that we'll be studying further. Moving on to the types of peptide that we can have. So peptide can be classified on the basis of the number of amino acids present in them. If we have two amino acids, we get a simple dipeptide as we did in the previous slides. If there are three, it's called a tripeptide, and similarly, we have oligopeptides, proteinoids, polypeptides, and proteins. So if we have more than 100 amino acids in a chain, it makes a protein. It's very important to know what is a terminal in an amino acid. So, since an amino acid has two functional groups, NH2 and COOH, it has two terminals. So, the NH2 terminal is named as the N-terminal residue, where we have the free NH2 group, and similarly, the COOH group is called as a C-terminal residue. It's very easy to learn them. As NH2, we take N, and from COOH we take C, and thus name the terminal residue. Moving on to end group analysis. So here I have a polypeptide chain, and as we can see, it is made up of various amino acids, but we don't know, for example, that what are these amino acids. So end group analysis means analyzing the end part of the polypeptide chain to know whether it is an N-terminal or a C-terminal. So if we want to identify the N-terminal, we'll do it by a method called Edmond degradation. And if we want to identify the C-terminal, which is the COOH group of the amino acid, we do it by two methods, carboxypeptidase enzyme, and the second is a thiohetone formation. So starting with the first method, which is the Edmond degradation. Now let us assume that we have a polypeptide chain which is made of several amino acids, but we don't know the identity of these amino acids. So now, according to the end group analysis, we analyze the end part of a polypeptide chain. In this case, the polypeptide is made of various amino acids, so we will analyze the first amino acid, whether its N-terminal is free or its C-terminal is free. So when we run this Edmond degradation test on this polypeptide chain and it gives a positive result, we can conclude that the N-terminal, which is the NH2 group of the first amino acid in this polypeptide chain, was free. So this reaction is very important because not only does it identifies the N-terminal amino acid, but it also helps us to remove this amino acid, leaving the remaining chain intact. So looking at the basic reaction which is given in this box, if we react the N-terminal of the polypeptide chain, which means a polypeptide having the N-terminal, the NH2 group of it free, with phenyl isothiocyanate and a reagent like HCl, we'll have the formation of phenyl thiohetone. Now we have to keep it in mind that the first or the last amino acid of a polypeptide chain has been cut out of the entire chain, leaving the remaining chain intact. So now when the first, or we can say the last amino acid was taken out in the form of phenyl thiohetone, it can be processed with the help of BaOH whole twice to make an N-terminal amino acid, and we can actually conclude that which amino acid was present, because in the initial case we took that we had a polypeptide chain with unknown amino acids. So Edmond degradation has two uses, the first being identifying the unknown amino acid through this way, and the second is confirming the identity of a known amino acid. Now let's get into the mechanism of Edmond degradation, how it's done step by step. So in the first step, we have taken a polypeptide chain. For the ease of writing the mechanism, we have taken a simple tripeptide. So according to the basic reaction, if we take phenyl isothiocyanate and react with it with the given reagents, we get an intermediate compound of this form, which is the step 2. In step 3, there are a lot of rearrangements going on in the intermediate itself. So let's see what are these. Firstly, the oxygen being electronegative takes the electrons from a double bond, leaving the carbon electropositive. Now, as we know that nitrogen has lone pairs, it would attack the electropositive carbon. And so this bond would move on to nitrogen, leaving a negative charge over it. And this hydrogen would get out having a positive charge and would attack this negative nitrogen, and this is how NH2 gets formed, and this part of the peptide chain would get out in the form of degraded peptide, and the remaining part would rearrange itself to make a thiohetone. Now this part would become over here, and this part would come over here, and this is the remaining part would get attached to make a thiohetone. Now R dash and R double dash signify that in this chain there are 3 amino acids linked together. So according to this reaction, the first amino acid gets separated out as thiohetone, and if we process it further with BaOH whole twice, we'll get the N-terminal amino acid, and this is how the N-terminal is removed. Moving on to the second condition, according to which the polypeptide chain actually has a C-terminal residue free. So if we want to identify if the C-terminal is free, we will react the polypeptide chain with an enzyme called carboxypeptidase. It is a very simple reaction where we'll simply take the polypeptide chain and react it with this enzyme. So what happens is this enzyme would shorten the polypeptide chain by taking out the C-terminal amino acid and would leave the rest of the chain intact. So in the next slide, we'll see how it's done through the mechanism. Here we are having a simple tripeptide. If we react it with this enzyme carboxypeptidase, this enzyme has a work to identify a free C-terminal, which is the COOH group. It would not do anything concerning the NH2 group. So this enzyme would selectively cleave the amino acid which was having a free COOH group, and this way it would come out and leave the degraded peptide chain as it is. Now if we again use this enzyme, it would again cleave the amino acid having the free COOH group, thus resulting in 2 different amino acids, because instead of a polypeptide we only took a simple tripeptide. Another method to identify if the end group of a polypeptide chain has a free C-terminal, we have a method called thiohetone formation. This is very similar to Edmond degradation, but with the difference that instead of cleaving the N-terminal, it cleaves the C-terminal of a polypeptide chain. So according to the basic reaction, when we use these reagents in the polypeptide chain, a thiohetone is formed from cooled alkali, and if we process it further, we'll get the C-terminal of the amino acid free from the main polypeptide chain. So in the next slide, we'll have a look at its mechanism. Here we have taken a simple peptide chain comprising of two amino acids. So according to thiohetone formation, this method selectively cleaves out the free C-terminal of a peptide chain. So let's see how it happens. So in the first step, when we react this peptide chain with these reagents, we get a compound of this form in the second step, and we can clearly see that the free C-terminal was reacted to form this entity. Now in the third step, when we react it with cooled alkali like NaOH, this entity would get cut out from the main peptide chain in the form of thiohetone. Now, when we react this thiohetone with BOH whole twice, we can retrieve the free C-terminal amino acid in the fourth step. So that ends our first part of the lecture, peptides. Let's have a quick recap at what all we did. So we started it with the basic definition of peptides, what type of bond do they have, and the N and C terminal that is present in every peptide chain. Next, we moved on to the end group analysis, which means we identified if the end of a polypeptide chain had a free N-terminal or C-terminal. So to identify an N-terminal, we did it by Edmond degradation method, and for C-terminal, we did it by two methods, the first being carboxypeptidase enzyme and the second is thiohetone formation. So I hope this video was clear, and thank you everyone for joining.